Today, we're going to learn how to analyze arguments by using truth tables. So the first thing we need to do is understand what an argument looks like. A logical argument consists of a list of premises followed by a conclusion. Now, sometimes an argument will have 2 premises, 3 premises, even 5 premises. Typically, the arguments that we see are going to have only 2. So there are 2 different types of arguments that we're going to see. Some of them involve words, some of them involve only symbols. On the right here, you can see the 2 different types. The first argument has 2 premises, and it says, it is cold, that's the first premise. It is raining or it is cold, that's the second premise. And then the conclusion is it is not raining. In the second argument, we only have symbols, so there's no actual words that go along with the argument, but either way, it's not going to make a difference. We're going to be able to use truth tables in order to analyze both types of arguments. Let's take a look at how. So the first thing we need to do is, if the argument is given to us in words, we need to translate that argument into symbols. So, for example, if we let P represent the phrase, it is cold, and we let Q represent the phrase, it is raining, this argument translates into, well, the first line is just P, it is cold. The second line says, it is raining, or it is cold, so that premise would look like Q or P. And then the conclusion, it is not raining, would look like not Q. The next thing we need to do once our argument is entirely in symbols is we need to take all of the premises and put an and sign in between them. So we're going to take P1 and P2 and P3 all the way until we hit our last premise, and we're going to put a large bracket around them. The last step is we create an if-then statement with the premises as our antecedent and the conclusion as our consequent. And this is exactly the compound statement that we are going to create for our truth table. So the last thing we really need to discuss is what to do once we have our truth table, or really what we are looking for. So we're going to have our P, we're going to have our Q in our truth table. There's going to be a lot of columns going on here, right? And then the very last column that you're going to see is going to be this very large, and it's not necessarily going to be fun, but this very large compound statement, this if-then statement that we've created. So here's the idea. When we have all of our truth values in this column, what we are looking for is we are looking for all of them to be true. If they are all true, then this is called a tautology, and the argument is a valid argument. All it takes is for one of them to be false to make it an invalid argument.